All right. Okay, hi everybody. So I'm going to talk about Geosphere. Geosphere is a website that allows you to visualize GO16 ABI data, well, the other ABIs as well. But it is not only the website, but also the processing backend. And I'm going to do this talk kind of jumping around chronologically, talking about what the goals of the project were, but then switch to what it actually looks like now in the development version, and then switch back to how it evolved and what kind of technologies are involved. And I'm glad Russ went first because I'm going to kind of skip over the containerized talk and skip to higher level stuff. So let's talk about me first. I'm a software developer at the SSEC, lead developer on Geosphere as well as Geo2Grid and Polar2Grid, which you heard a lot about yesterday, and lots of other projects including SIFT, which you may have heard of. I'm also a pretty active open source developer and contributor. I'm a core developer on the SatPy and PyResample Python libraries and a core maintainer on VizPy, and somehow I tie myself to a ton of other projects. The rest of the Geosphere team, we have Clayton Saplinski, who's our only front-end developer, so everything website-wise, that's him. Ray Garcia and Will Roberts are back-end developers. They've been working a lot recently on adding additional products to Geosphere. We have Graham Martin, who's the PI and fills in every other gap of the project, tester, proposal writer, report writer, everything. Scott Nolan, Jesse Stroik at our technical computing. Every time we break the cluster, in some sense, they're right there to fix it. So I wanted to make sure to mention them. So Geosphere has kind of existed for 2 years now. I know that because my daughter was born 2 years ago, right before the project really got going, and she just had her second birthday. So we're in the middle of near the end of our second phase of funding. The original purpose of the project was to take GO's rebroadcast or GRB data and get it in front of the user as quickly as possible as image tiles. So as low latency as possible, but we wanted the imagery that was shown to be CSPP Geo2Grid output, so the geotiffs and the high resolution true color images and that kind of stuff, and have that data be processed with CSPP GeoGRB, then Geo2Grid, and then get it somehow to the user. We wanted to use more modern technologies. Whatever cloud means to you, we were trying to be cloud friendly in our development to support multiple environments if we needed to. So whether we wanted to do that in the commercial cloud like AWS or Google Cloud or our own on-premises cluster. So we wanted to keep all of that in mind. On the user side, we wanted to make a good-looking website, but we wanted it to be simple. We didn't want to have too many options. That's both for our own purpose, just to ease the development, but also for the user so that they're not distracted by too many things on the screen. You want to look at the imagery. We had to do this on a budget. So we had 2 developers. It was me on the back end, Clayton on the front end. That also meant one self-hosted server when we first started out. As I kind of mentioned, we wanted to do development in a cloud-friendly sense, but also just learn stuff about Kubernetes and all of these types of technologies so that not only to benefit our own project with Geosphere, but the rest of the CSPP group and just other projects that we work on at the SSEC. So that was all phase 1 stuff. Around the last year or so, we've been doing phase 2, which has included adding more products, adding more features, like being able to share video animations from the website, and lots of optimizations. We haven't finished all of them, and I'll point that out in a little bit. So I tell myself I never want to do a live demo, but for some reason it seemed like the right choice today. So I'm going to try this. Maybe it's because it's the first time back at an in-person conference, and let's just take the risk. So this is, I should point out, this is the development version of the website. You can only get this if you're on the SSEC or the Wisconsin network. So Geosphere-test, you could probably use it. You should be able to access it here if you want. But yeah, in development, so these features are not on the production website yet. So this is our main interface. I'll just kind of point out what the different elements are. So in the upper left, we have the logo for CSPP Geosphere. It's also clickable, and I'll show that in a sec. Under that is the menu, which lets you choose what you're looking at, what products. Another feature of this is that if you stare at it long enough, the menu and everything disappears, so you can still look at the imagery. So you can choose what products you're looking at. There's also a couple toggles and features, which I'll go over in a sec. That's all controlled through that menu. In the upper left, we have the time of the image that you're looking at. In the middle, you have the actual image that you're looking at. Lower right, you have zoom controls and more information about what zoom level you're looking at. And then at the bottom is all of your time and animation control, what times you're looking at. There's also a button to share what you're looking at. So if we start out with the top left, if you click the logo, this gives you information about Geosphere, where it's getting data from, what type of processing it's doing. It also links to the GeoGrid documentation, specifically the pages that tell you how these products are made, what corrections and enhancements are applied to them. So hopefully you can get as much information as you want about that software. There's also a contact form that you can get to if you have any questions or comments or find something wrong with the website. So on the menu on the left, right now there's Go 16, 17, and 18 as your options. We only support ABI data right now. You can choose any of the 4 sectors that ABI has: full disk, CONUS, the 2 mesos. You can choose between 17 different products, the 16 basic bands, I guess I'm going to call them, from ABI, as well as what we're looking at right now, which is true color on the day side and a night microphysics on the night side. The last 2 options here are for controlling whether or not the coastlines show up, so I can click on and off there. Grid lines for if I want to see lat long lines. And then the last option, which I skipped over, is the auto reload. So this Geosphere will check back with the backend every once in a while to see if there's new data. And when there is, and you're looking at the most recent imagery, it will automatically pull it up, even if you're animating. So you can kind of just have this as a dashboard and just continuously see the imagery coming in. So that's it for the menu. One small feature on this upper right time is you can actually click the time zone and it'll switch the time to your local time. That might help you figure out what times you want to look at and help you figure out what you want to look at. There is a zoom to window button in the lower right, as well as plus and minus for controlling the zoom. You can also zoom in and out with your scroll wheel. The map in the middle is in the native geostationary projection of the ABI instrument, so there's no resampling going on. This is what the data looks like. If we zoom in, we can see that that higher resolution tiles are loaded, and they do get cached on the back end, but I have not looked at this data yet today, so unless somebody else is looking at this, this is like raw live speeds of what's going on here. And so this is full, since these are GeoGrid products, this true color is at the full 500 meter resolution of the ABI data. All the other lower resolution bands are upsampled so that we get the prettiest picture we can get. Go back to zooming. On the bottom, we can animate. By default, it'll show you 12 time steps initially. And so if I don't know if you can see it, there's a little progress bar on the bottom that will make sure that all the time steps for your animation are loaded before it continues playing the animation. There's a forward button, so by default it's playing in a normal forward animation, but we can also do a rocking animation, so it'll just go back and forth. Some people like to look at the animation that way. Control frames per second, so 10, 20, 30, or go back to 1, 2, 5, or 10. Play pause. So the test website doesn't retain that much data. We have a couple days here. The production website is a few more, but we can actually select what times we want to look at. So I said by default it's the most recent 10. I can also pick a start time. So let's say this morning, and I can say I want 10 frames, and then I can say I don't want every time step, I want every 6th time step and do some kind of striding. So when I click select pattern, this will show me what times I've actually selected. I could also manually select times that I wanted. Do some weird pattern if I wanted to do that. I can also do most recent 10 and still do the striding, select that. So I got 10 times there. I can click update, and it will actually upload or update what times I'm looking at. Since it was already on the image that was loading, it doesn't really look that different. But if we step through here, we can see we're looking at the times that I specified. Let's see. For the share menu, depending on what you're looking at, you can share different URLs with to let other people see what you're looking at. So you can, if you're looking at a specific region and you want somebody to just see what the most recent frames are for that region, you can use the most recent URL here at the top. If you are trying to show somebody or you want to come back to it a specific time at a specific region, you can use the absolute time, so it'll make sure that you're not accidentally pulling in the most recent frames. You can save a PNG, and I have not tested any of this on this laptop yet, so let's see how good this goes. So I saved an image, I get exactly what I'm looking at, all the controls are removed, all the menus and things. The Geosphere logo is kept there, the SSCC logo in the bottom right, and then all the other information is replaced with a banner at the bottom with the satellite instrument, what product you're looking at, the time, and that kind of stuff. So let's try to find the browser again. So I mentioned you can save a video, and so I click that, eventually it'll download it. It's giving all this information because from a developer point of view, this is really interesting. It's actually making the video on the client. It's not going back to our servers to generate this. It's using the frames that you already have here. That does mean it's dependent on the power of your system, but depending on, it's also dependent on how many frames that you're trying to load. But so I had 10 frames, which isn't that many. But so I downloaded a video, here it is, I have it. Same kind of things as the image are true for this video. There's a banner at the bottom with all the information. And I hope that's all I wanted to talk about. Yeah, let's actually load. Let's load the most recent time steps. I didn't show it off well enough. Oh boy, Kathy. Do I get extra time if I explain this? So what goes into these, specifically the true color, there's a lot of steps to try to make it look pretty. So we load the data. I already talked about upsampling. So it'll replicate the pictures for the, or pixels for the low resolution bands. There is Rayleigh correction. There's it divides by the cosine of the solar zenith angle, which is just a normal reflectance kind of deal. Ratio sharpening, I don't know if I said that. So it'll actually take a ratio of the high resolution band to a lower resolution version of itself and use that to sharpen the other bands. I think that's all I could say. And I do have a video at the end of some mezzo. Depends what you want to look at. Okay, I want to talk about the nerdy stuff, so we're going to go back to the slides. Okay, so that's it for the front end of Geosphere. I'm going to talk a lot more about the back end now. This is a little more low level and it's less pretty than looking at pictures, but I have to talk about it. So we knew in phase one we wanted to take the satellite data and get it in front of the user. we knew we wanted to do a website for that because we didn't want somebody to have to install anything. We just want to look at it. We looked around at a couple different solutions, ended up going with open layers as our, on the client side, reviewing things, as well as Proj4.js for doing some of the projection math. To support those native geostationary projections, we actually had to contribute to the Proj4.js library. So if you are a programmer and you've tried to use Proj4.js before, geostationary projections are now a thing in there. We did have to make up some APSG codes on the back end and the front end to make all of this stuff work, just because usually scientific or weather satellites don't have special APSG codes and projections and all that stuff. So we had to trick the software into doing it. On the further back-end side, I already talked about we wanted to use GRB and GeoDegrid to process the data. But then GeoDegrid's, so GRB is producing netcdf files. GeoDegrid is then taking those and turning those into geotiffs. But how do we get the geotiffs to the website? I searched around for a lot of different solutions, and I stumbled upon MapCache, which is a server that you can run that provides an OGC standard WMTS service. And what I really liked about MapCache is that you have the flexibility to point it at many different services that provide tiles or imagery in some way, and it'll cache them. You can even point it at other instances of MapCache, so you can do this chaining effect of having some really fast cache on the client side or near the client, and then further back, maybe you're going back to a spinning hard disk or even to S3 storage further back, just so you can chain these things together. But MapCache itself does not necessarily understand geotiffs, at least not the way we need it. So I also had to add MapServer to this. So MapServer is made by the same people who make MapCache. It serves data as an OGC WMS service, but it also doesn't really understand, or it doesn't automatically know how to find new times or new geotiffs. So we had to write some more custom code. This is just custom Python code that updates MapServer to say, here's a new geotiff, here's the time for it, here's the bounding box. But then, of course, the website needs to know what times are available, so we created an API for that. And this is really the basic structure of start to finish what Geosphere is doing. It's running on Kubernetes, and all of these things are communicating with each other, but I'm also leaving out a lot of complexity in this diagram, but this is really the start. This is where we started. The things I'm leaving out are the RabbitMQ or AMQP notifications or events that we're using to communicate between all of these components. There's the storage that has to be managed for the netcdf files and the geotiffs. There's shape files, which is what MapServer is using to store the time and geotiff information. And then there's actually also a PostGIS database, because that worked best for how MapCache needed to talk to things. So we rushed to get this all working for phase 1, and then phase 2, the first thing I wanted to do was get rid of shapefiles. So that's that's the first part of phase 2 that's actually finished now. MapServer is now talking to PostGIS directly. So that's the complexity of the backend, and I'll talk a little bit more about where we want this to go in the future. First, I want to talk about the other big change that happened in phase 2. In phase 1, we had that one single server that I mentioned, and we called it a cluster because it was running all the Kubernetes stuff that it needed to run. But a cluster is, I mean, I guess it can be one node, but it shouldn't be one node. That kind of defeats the purpose. So we've finally actually moved to a real on-premises Kubernetes cluster, multiple nodes, and it's helped us a lot. It lets us distribute our processing across multiple nodes. It gives us flexibility as far as if a node goes down, or having multiple instances of the same service so that they can be served from multiple systems, whether or not one is bogged down doing some type of processing or something. Other things for phase 2 that are either done or we're working on, I recently upgraded to a beta version of GeoDegrid. As I said, I'm the GeoDegrid developer, so it's very easy for me to do that for myself. We hope to release GeoDegrid, well, Kathy will talk about that, but that beta has basically cut the memory usage of our processing in half, as well as made it faster. So look out for that new version, or if you want to be a beta tester, let me know. I have tar balls for you. Clayton added the ability to do those MP4 videos that I showed. I recently just switched the API that we built from using CGI scripts, which were very hacky. I've started playing with the Python Fast API framework. Very soon, we hope to switch Goes 17 and Goes 18 in that menu to just Goes West, similarly Goes 16 to Goes East, so that when there's these interleaving periods with Goes 18, you, the user, don't notice anything. It just switches automatically to the new satellite. It'll show what satellite it's showing, but just so that you don't have to have this weird switching between, because you really want to compare them and animate between the different time steps between the two different satellites, since they're covering the same region. Other optimizations we're considering are larger image tiles. This should result in less requests and hopefully just faster downloading of the tiles. We are right now producing PNG tiles, and we hope to play with JPEG compression. We assumed, or maybe incorrectly, that JPEG would, being a lossy compression, would affect the image quality of what you're looking at. But doing some basic comparisons, you can't tell the difference. So JPEG compression just cuts down the size of the images, the size of the tiles, and it just should be better all around. We just have to actually switch to it. We also want to play around with the newer modern browser technologies that allow you to do something in the background. So you have client doing something to the user, but preparing something in the background, like preloading frames and that kind of thing. And then we're also working on more products, ABI level 2, possibly other RGBs, and a lot of other features. And then the last thing I wanted to talk about, Russ talked about S3 a lot. That's something we're currently not using, but we're very close to using. And the reason that's important is because I lied about how we're using our cluster. So I talked about the cluster and how it has multiple nodes. We can spread this work out. But since we're not using a distributed storage solution, like something that supports S3 protocols, our geotiffs are essentially a directory on one of the nodes. They can't move around. They are on that one node. So if we think about what processing needs those geotiffs, we have GeoGrid producing the geotiffs, and then map server and a tile indexer using the geotiffs. But GeoGrid also needs input, so it needs netcdf files. So there's also the netcdf storage on that node, which means GRB also has to be on that node. So GRB processing is all on that one node. So we've gone from wanting this nice distributed processing to putting a lot of work onto one node. So we have CephFS installed on our cluster. That provides an S3 protocol, and essentially, as long as our software supports it, which it does or will, we can, from any node, request data, and Ceph will figure out how to get that data to us, wherever it's stored on the node, or on the cluster. So theoretically, we should be able to have GeoGrid one place, GRB another, map server another, or even actually replicate these things, because there isn't a whole lot of, there isn't a good reason to have multiple instances of map server if they're all on the same node. But with this solution, map server could be on all of the nodes and handling requests in parallel and doing things hopefully very fast. So I'm really looking forward to that. That's why I wanted to end with that. I want to say thanks for listening. Also thanks to all our beta testers who I've listed here. There are URLs here at the bottom, but I'm also going to go away from this slide so that I can, or not, if I miss the click. So this is it's only 24 seconds, but it's actually 4 hours of Goes 16 ABI Mesoscale 2. I almost wish I zoomed in more. That's all I have. Thank you.